Have you ever been there? Gearing up for a big project, maybe integrating two massive data systems or uh, coordinating some critical software launch, and you just hit this wall.
Mm-hmm.
That awful feeling where everyone's using the same word, like, say, active user or maybe in-scope risk, but deep down you realize, oh no, they all mean something subtly, structurally different.
Yeah, that semantic quicksand feeling.
Exactly. And that feeling where, the supposed best practices are meant to bring order, but somehow just make coordinating impossible. Well, that's not just a management headache. It's a sign your system is caught in a structural trap.
And that trap is really what we're diving into today. Our mission here is to unpack something called the Freedom Inversion Principle, or C7 though for short.
C7, okay.
Yeah, and this idea, it comes from the foundational work of Elias Moosman. His background is pretty wild, like a 25-year journey spanning everything from building early graph data science models to high-stakes Fortune 500 restructuring and even advanced AI alignment research.
Wow, quite the range. So the core idea we're tackling is this paradox, right? It sounds almost backward. We think freedom means flexibility, having options.
Right.
But these sources, they argue the opposite. They actually posit that constraint creates freedom and flexibility creates a trap.
It's deeply counterintuitive at first glance.
Totally. And we're apparently going to prove this structural principle using things you can actually measure, like physically measure, like a database cache miss rate.
Exactly.
Yeah.
We're taking it out of pure philosophy for a moment. We are talking about verifiable physical reality happening right there in your server rack.
Okay, I'm intrigued. Let's get into it. All right, so let's really unpack this. It feels wrong. We're trained, especially in modern business, software development, flexibility is king, right? Agile, adaptable. Why would allowing, arbitrary freedom in defining our terms make us less free? Isn't defining agile however my team wants? Isn't that the essence of agency?
Well, that's the crux of it. It feels like agency, but it can actually lead to captivity.
That's freedom inversion.
Yeah. When you let symbols, and that could be data fields, architectural concepts, even just the words we use day to day, when you let them drift freely without fixed coordinates in some kind of defined semantic space, you actually create entrapment.
How? Why?
Because you end up constantly controlled by ambiguity.
Yeah.
Every single interaction, every decision requires you to stop, pause, and figure out, wait, what do they mean by that? You burn energy just disambiguating.
Okay, so the flip side is if symbols are constrained, if we pin them down to a precise measurable location in this semantic space, that's what unlocks freedom, agency for the people using them.
Absolutely. The very moment a symbol loses its fixed ground, we get trapped, verifying its meaning over and over. But when it has a precise, agreed-upon position, verification becomes almost instantaneous.
Go on.
Constant time.
Instantaneous.
Right. And that gives you the agency to reason deliberately, quickly, effectively. Drift feels like freedom, but it's actually semantic captivity. Precision feels like constraint, but it's liberation.
Okay, conceptually that makes sense, but I still need some proof. Does this semantic structure, this space, even exist? Language feels so messy. Why do we have thousands and thousands of words for slightly different things if meaning is so structured?
Well, the plurality of language, the very fact we have thousands of words, is the proof itself.
Oh, so?
Think about it. If semantic space wasn't structurally differentiated, if there were no, say, orthogonal dimensions separating concepts, we'd only need one word for everything.
Just.
Exactly. We have thousands of words precisely because they occupy different, structurally distinct, measurable coordinates within that semantic net. The existence of chair, stool, bench, sofa. It proves those concepts aren't the same. They occupy different coordinates.
Okay, different coordinates. But meaning does change, right? You mentioned the word nice earlier. It used to mean foolish or silly centuries ago. That's a classic example of semantic drift. How does that fit into a fixed structure?
Right. Great question. That's where the snapshot principle comes in. Words drift over historical time, absolutely.
Oh.
But, and this is crucial, they drift within that structured orthogonal net. Communication, understanding, it only works to the extent that you and I are looking at the same structural snapshot.
Snapshot, like same time period, same culture.
Same era, same culture, same domain, yeah. If I try to talk to you using, say, a 17th century snapshot of English meanings, you won't get it. Not because the structure dissolved, but because our relative coordinates for words within that structure are misaligned. We're reading different maps.
Okay, so understanding requires sharing a structural snapshot, a constraint. Makes sense for talking. But how does this lack of constraint become a, catastrophic problem when we try to build systems? like data systems or software.
Right. This is where the trap stops being philosophical and starts costing you real money and real time. The cost of those ungrounded drifting symbols is what the author calls the TN verification explosion.
The cost of ambiguity just ballooning exponentially.
Yeah, think about it simply. Let's say you have a project, just 3 critical terms: client, product, and revenue.
Yeah.
Simple enough, right? Okay. But let's imagine in your system, client could mean A or B. 2 interpretations. So T2.
Right.
Maybe product could mean C or D. Also T equals 2. And revenue. Maybe it can mean gross or net. Again, T equals 2.
Okay, so N equals 3 terms, and T equals 2 interpretations for each one.
Exactly. Now, to perform even a basic reasoning step, like what was the revenue generated by this product for this client, you suddenly face T to the power's N, so 2 cubed. 8 distinct disambiguation paths you potentially have to check every single time. Now, add just one more ambiguous term, say market, also with 2 meanings.
That's 2 to the 4.16 paths.
Immediately doubles. Now, imagine N isn't 3 or 4, but hundreds or thousands of symbols in a huge enterprise system. That exponential curve, it makes verification completely intractable.
Okay,
The system gets trapped, bogged down in ambiguity. And that manifests as complexity, fragility, bugs, delays. Sound familiar?
Oh, yeah. I've definitely lived the pain of writing, like a 500-line SQL query, basically, just to force the system to understand what I mean by client in this specific context. But where does this structural mess come from? I mean, we use industry best practices, right? Normalization.
And that is precisely the issue identified in the source material. COD's normalization, the traditional relational database best practice, is argued to structurally fail the constraint test. Why? Because it explicitly decouples physical position from semantic meaning.
Hold on.
It violates what the author calls the unity principle, say PH. Semantic meaning must equal physical position must equal hardware representation.
You're saying the bedrock principle of most of the world's data architecture is actually the source of the trap. That sounds pretty radical.
It's a structural critique, yeah.
Yeah.
Not about intent, but about the geometry. In a typical normalized database, think about it, semantically related data, like all the different attributes of your client, they get scattered across totally arbitrary memory addresses.
And linked by foreign keys, ID.
Yeah. Exactly. Connected only by these arbitrary logical pointers. The system fundamentally loses any geometric relationship between concepts. Semantic neighbors are not physical neighbors in memory, and that decoupling, that scattering, is the fundamental structural source of the semantic drift and the TN verification explosion.
So we deliberately broke the geographic link, introduced structural chaos in the name of, what, reducing redundancy? And we've been paying this hidden exponential price ever since.
That's the argument. And here's the kicker, the big reveal where, as I said, philosophy becomes hard physics. The cost of that structural trap, it is directly physically measurable in your hardware.
Wow.
When a normalized database tries to execute a complex join operation, it has to go find all that semantically related but physically scattered data. It's hopping all over memory, right? Whereas the observable physical result of the CPU being forced to search far and wide across random memory for data that should have been right next door.
Latency, slow queries.
Worse, it's a cache miss. A cache miss isn't just some random performance glitch. The source argues it is the hardware screaming, symbols ungrounded. It's the physical, measurable manifestation of that TN verification explosion, trying desperately to resolve a geometric relationship that the architecture itself explicitly destroyed.
Wow. Okay. To think of that tiny, like 100 nanosecond hardware penalty, but multiplied geometrically across millions, billions of operations as a direct signal that the fundamental architectural principle, SEAO, has been violated, that puts a whole new spin on cache miss rates.
The cache miss rate becomes an ungrounding detector. It's literally telling you in nanoseconds how much time tax you're paying because your symbols are structurally unable to be verified efficiently because meaning and location are divorced.
Okay, the urgency here feels immediate. If you're listening, your production database, it's likely trapped in this right now. That wall clock latency you measure, the milliseconds ticking away, it's not just network lag or disk speed. A huge chunk of it is likely the hardware wrestling with this exponential verification cost caused by ungrounded symbols. You've normalized the pain, haven't you? You've thrown caching layers, faster SSDs, complex indexes basically, more hardware compensation at a problem that is fundamentally structural instead of fixing the actual trap, the ungrounded symbols.
And this structural trap, this constant fight against ambiguity, it leads us directly to another core principle from the sources, the principle of asymptotic friction.
Asymptotic friction.
Now, this principle explains why that last mile of any major data integration or system overhaul or even just bug fixing feels almost impossibly hard.
Right.
In these normalized, geometrically broken systems, as you try to get closer and closer to perfect precision P, approaching 1, meaning zero ambiguity, the required verification cost increases asymptotically. It heads towards infinity.
Ah, so that's why the last 5% of bug fixing takes 95% of the time. You're literally stuck on an asymptotic curve. You're putting in linear effort, more hours, more people, but you're only getting these tiny logarithmic gains in actual alignment or correctness. It feels like running through molasses.
Precisely that. You are structurally doomed to forever chase perfect clarity, perfect alignment, because the very structure of the system demands a practically infinite amount of verification effort to achieve it.
Wow.
And this structural reality, it creates this massive, often unseen existential cost. Just vast, preventable waste.
What kind of waste?
Destroyed potential, lost human fulfillment, just gratuitous suffering within organizations caused by these perpetually high coordination costs, a constant friction. And seeing this same pattern repeat this is key. Seeing it across 6 wildly different domains over 25 years, that's what created this, this moral imperative for Moosman to define it and figure out how to actually solve it structurally.
So if we're trapped on this infinite curve, just throwing more resources at it, faster CPUs, more memory, that just makes the system bigger, more complex, and actually deepens the trap, right? It doesn't change the asymptote.
Exactly. You can't escape the asymptote by running faster along it.
So how do we escape?
The only way out proposed is a structural reorganization, a fundamental shift in the system's geometry. It's called a phase transition, A3.
Phase transition, like physics.
Just like physics. Think water turning to ice. There's this formula described, ACEEAN, which represents the state of precision in the system. C is connections, E is interpretations, N is symbols. When the overall precision crosses a certain critical threshold, AT equals critical, the entire behavior of the system fundamentally flips.
So a small change in precision, maybe getting meanings just clear enough, causes a total change in the system state.
That's the idea. Below that critical threshold, asymptotic friction dominates. Cost explodes, progress stalls. But above that threshold, when meaning becomes structurally fixed to physical coordinates, when CP is respected, you unlock something called compounding verities, F7 up.
Compounding verities. Okay, what's that?
Verification stops being this exponential nightmare. It becomes O1, constant time. Checking meaning is instantaneous because it's baked into the structure of the location. And when that happens, every new verified truth you establish doesn't just add linearly. It instantly enables potentially exponentially more truths because they're all geometrically connected and verifiable.
Ah, so the system's geometry stops fighting you and it actually starts working for you, compounding knowledge instead of compounding costs.
Precisely. You flip from a cost-exploding regime to a knowledge-compounding one.
Okay, and what's really compelling about the sources here, as you mentioned, is the real-world application. This wasn't just cooked up in a lab. Moosman apparently saw this exact same core coordination failure pattern and reportedly solved it using the same semantic grounding, this geometric constraint idea, in totally different fields.
Yeah, it wasn't about pivoting domains. It was about recognizing the same underlying structural problem manifesting differently. He saw the toddler attempts, as he calls them, to formalize semantic addressing way back in graph data science in 2005. Then, completely different context. Applying this geometric constraint idea to human incentives, aligning goals, when turning around a struggling language school in Dubai between 2015 and 2021, basically coordinating conflicting stakeholder incentives by grounding what they meant.
Fascinating. From graphs to school management.
And then the big one, the sort of high-stakes enterprise validation, came in 2023. Hired by Scania Group, huge Fortune 500 industrial company, for a really mission-critical, agile R&D transformation. And the core recommendations they implemented were reportedly based on fixing this exact pattern of coordination failure through semantic grounding.
So graph data, education, Fortune 500 manufacturing R&D. The claim is the underlying structural physics of coordination is the same.
The pattern seems universal. The geometric relationship between meaning, semantics, and physical position dictates the speed and cost of truth, of coordination. And let's just reiterate that really profound personal insight about freedom.
Right, the inversion.
If you think about personal freedom, like perfect alignment between your mind and your body, would that make you more or less free? Most would say more. Closing the gap is freedom. Similarly, closing the gap between what a symbol means and where it physically sits in a system applying that constraint, fem, It actually reduces the degrees of freedom for the symbols, forces them into coordinates.
Which sounds restrictive.
But the result is dramatically increased freedom, agency, and control for the humans or agents using the system. When symbols are allowed to drift freely, ambiguously, we lose control. We become slaves to verification.
Okay. And this brings us to the really urgent part. You mentioned AI.
Yes. The urgency is massively amplified by AI.
Yeah.
Look, human correction mechanisms for ambiguity kind of work, albeit inefficiently because we move relatively slowly.
Yeah.
We can pause, call a meeting, clarify that term that caused confusion last week.
Right. We have built-in latency for correction.
AI operates at light speed, milliseconds, microseconds. When you have multi-agent AI systems trying to coordinate based on symbols that lack this structural semantic grounding, that the semantic drift, the TN explosion, it doesn't just happen, it compounds geometrically, almost instantly.
With no time for human force correction.
Exactly. There's no, let's pause the world and have a meeting. The structural trap accelerates potentially towards catastrophic coordination failures before we even realize what's happening.
And the argument is that current approaches to AI safety or alignment are missing this.
The argument is that many current attempts are structurally incapable of addressing this fundamental speed of drift problem because they haven't fixed the underlying semantic geometry first. You're essentially trying to build a super fast tower of complex coordination on a foundation of built-in structural ambiguity. That's unstable.
Hashtag tag outro.
Okay, wow. Let's try and wrap up this pretty intense deep dive. We started with this really counterintuitive idea. Constraining symbols actually creates freedom.
And we've journeyed through how this isn't just some abstract philosophical point. It's presented as a measurable physical phenomenon. Your database's cache miss rate is potentially the hardware screaming that symbols are ungrounded.
You have the physical cost of ambiguity.
Forcing your systems onto that painful asymptotic curve where getting things right gets exponentially harder, where linear effort just yields logarithmic progress.
And the core problem identified isn't the inherent complexity of the world. It's what the author calls the normalized splinter in our current architectures.
The normalized splinter.
Yeah, that accepted, often invisible, structural gap between what our systems say and what they actually mean. That gap is the structural source of asymptotic friction. And knowing this gap exists, knowing its cost, and crucially, knowing there's a potential path to fix it via phase transition. Well, the source argues that makes inaction a choice, with a measurable moral cost in wasted potential, friction, suffering.
So the final thought for you, the listeners, is maybe this. If you can now start to see, maybe even measure, the precise physical cost of symbols lacking fixed meaning in your current systems, that latency, those bugs, that coordination overhead, what will you do differently?
What will you do to avoid building the substrate for the next intelligence, whether that's your next big software project, your organizational structure, or even artificial intelligence that contains that exact same geometrically compounding structural trap?